Hey guys, the last video got cut off. I have a loose connection, a loose wire on my dock cam, and sometimes when I bump it, it cuts off the video. It unplugs the camera. So what I was talking about is this one, number 3, and I was just saying that I'm okay if you skip this one in terms of your homework. Now I am going to go over it because there's an important idea that I want to talk about that will be used later in the assignment. And just for people that are curious, I'll kind of walk through this one. But after I go through this one, I'm going to just kind of give you hints on the last 4. So if you want to kind of skip to that, you can. But for right now, I'm going to go through this proof. Now, the first thing I want to do is kind of see what triangles I'm talking about. So the triangles that I've given are congruent are these 2 dark blue ones. Okay? The triangles that I want to show are congruent are actually overlapping each other. It's this guy right here, which I've drawn there, and then it's this guy right here, which I've drawn over here. Okay, so this is a little bit confusing because of that overlap going on. Okay, but I did want to talk about what you know when you have a given triangle congruent statement. So this statement is saying that this blue triangle is congruent to this triangle. And what we said earlier today in class, we talked about when you know 2 triangles are congruent, you know that there's 6 pieces of information that you've just been given. And that all comes from what we call a CPCTC. The corresponding parts of congruent triangles are congruent. Okay? So when you're given this in the very beginning, you know a lot of stuff. You know that this side is congruent to this side, and this side is congruent to this side, and this side is congruent to this side, and you know this angle is congruent to this angle, and this angle is congruent to this angle, and this angle is congruent to this angle, right? You got all that stuff going on here because of those 2 triangles. Now it turns out we don't actually need all of that stuff, but we're going to need some of it. So right off the bat, 2 of the sides of these blue triangles are 2 of the sides that I need for my longer triangle, right? So this is a side, this right here, HG, is a side of this guy, but it's also a side of this longer one. And so since these 2 guys are congruent, I can say that these 2 guys are congruent. So HG is congruent to KL, but those are on my longer triangles as well. And so that's what I have right here. So starting from the given, I know that these guys are congruent by CPCTC. Okay? So this pathway right here is giving me one of my sides of the triangles I'm after. Okay, we're actually going to use side, side, side on this one. Okay, we're going to come back to that idea in just a second, but let's talk about the easy stuff first. Okay, the other thing I know is that these triangles were sitting on each other, right? So they both have the bottom segment GL, right? Now they're kind of overlapping here, but if you break them apart, you can see that that segment has to be congruent to itself because of the reflexive property. So the bottom of the triangle is the same for both of them, and I just said GL is, that should be congruent. Congruent to LG, reflexive property of congruence. So I'm actually like 2/3 of the way there already. That's not the hard part, that's the easy part, okay? So I use CPCTC to get these 2 congruent, and then I use the reflexive property to get the bottom 2 congruent, okay? So I just need a 3rd side. Now you can also use CPCTC to get you this top angle, but that's not an included angle, and so you can't use that in your proof. You can't say side angle side because it's not the included angle. So there is a way to prove it using those top angles, angle GHL and angle LKG, but you're going to have to get another side, and that takes some work. Okay, so let's talk about how to get that 3rd side. Okay, now notice that this whole side, this long side right here, is made up of these 2 shorter segments. So you can't really it's hard to see it in the picture, but basically there's these 2 parts, right, of each one, and this guy is congruent to this guy, and then this segment here is congruent to this segment. So you got this long segment, this long segment here that's made up of 2 smaller congruent segments. So essentially what you're going to do is you're going to just use the segment addition postulate and say, look, these 2 segments form the bigger one, and these 2 guys form the bigger one, and since, small plus medium is going to equal long, those things have to equal each other. But this is kind of the pathway of how you do it. So you start by saying this guy. This was J, by the way. So HJ is congruent to KJ, and then you got JL congruent to JG. So that's just saying that these two are congruent to each other and these two sections are congruent to each other. Okay, that's what I got right here. Okay, then we just make a statement to say that these are equal in measure and these are equal in measure as well. So that's just definition of congruence. Okay, then the tricky part is when I add these two statements together. Okay, so I add this statement to this statement. So HJ plus JL is equal to KJ plus JG. Okay, that's actually the addition property of equality, saying if I add equals to equals, then I get equals. So if I add equals to equals, the results are equal. That's kind of what's going there. And then I use the segment addition postulate to say that HJ plus JL is HL and JK plus JG is KG. And that's what I have right here. So that's the segment addition postulate. So kind of combining these two guys, doing a substitution, I can replace this with HL, and I can replace this with KG, which is what gives me this statement, that the long segments are equal in measure, and then I can say that they're congruent. Okay, so that kind of sucks. And I'm sorry about that. I was trying to grab two proofs that would have you using CPCTC, or two proofs that kind of gave you a congruent triangle at the beginning, and just didn't realize that it was going to take so much work to get that third side. So that was kind of my bad. But you can kind of see now how that works. Again, probably wouldn't expect you to know how to do all that stuff on your own. That's kind of brutal. The other two steps I want you to know, though. How do we get these two sides? It's from these two congruent triangles. And then how do we get these two sides? That's from the reflexive property. Okay, that's going to be helpful for a future proof. And in fact, that same idea is going to be used on number 6. So notice that one of the givens in number 6 is congruent triangles. Okay, so that's going to be important in number 6. Okay, now that that's done and over with, and well, let me give you kind of a shot of that so you can see it. Okay, if you want to pause it there and copy it, you can. But like I said, I'm not gonna worry too much about number 3. I feel like that was just kind of my bad for not looking closely enough at it. You can kind of see how number 3 and number 6 are very similar, and that's what I was trying to go for. But this one is much, much, much easier. All right. Okay, let me give you some hints here on the rest of this. Okay. All right. So on number 4. We got a couple things, okay? The key word here in the given is bisect, okay? So I would probably look that up in the glossary if you want to, but bisect just means cut in half, basically. So DE and BC bisect each other. Okay, that means they cut each other in half, which means that these are congruent and these are congruent. Okay, that's just the definition of bisect, so that's pretty easy. You also know that these are vertical angles, and now you got SAS. Okay, so you're going to prove these are congruent to each other, and I'll give you a hint. You're going to use SAS, and I just gave you how you're going to get the two sides in the included angle. So you're going to get, sorry, oh, I put this in the wrong spot. My bad. Okay, so these two guys are congruent, excuse me, DG and EG, and then these are congruent, BG and CG. Okay, also the angle DGB is congruent to angle EGC, and you can use those to say that you got congruent triangles. So that's the gist of that one. Okay, again, I would do a flow proof if it was me, and I would do side, angle, side, and I would just talk about each one individually and then merge them all together to get your final thing. Okay, number 5. First it says that CDE is isosceles. Now if you didn't know this, an isosceles triangle is a triangle that has two of the sides congruent to each other. So there's lots of different ways to draw this, but here's an isosceles triangle. Isosceles means that two of the sides are the same. Not all three, that would be equilateral, but these two are congruent to each other. So the markings that you see here are because of that isosceles idea. That's really coming from isosceles. So they are marked congruent, but that's kind of part of this given. So when you're doing your proof, if you just say CD is congruent to ED, if you want to say that that's the case, you can say that, you can say given, or you can say like definition of isosceles triangle, or either or. But notice they're talking about this triangle, right? CDE, like the big triangle. And then we got these two little triangles formed by that big triangle. So that's how you get those two sides congruent. Okay? You also have that G is the midpoint of CE, which means that these two guys are congruent by definition of midpoint. Right? So remember that midpoint is a point that cuts a segment into two congruent segments. Right? So definition of midpoint will get you there. And then the last one is reflexive property. Like DG is part of both triangles. So DG is congruent to DG. So you're going to prove this one by side, side, side. Okay, that's going to be like your final justification. Your final line is going to look like this. Your three sides come from the definition of isosceles triangle, or given, from the definition of midpoint, and from the reflexive property of congruent segments. Okay, number 6. So this guy, this is the one that I was trying to help you get to with number 3, and that was kind of a mess. But let's talk about what we know. Okay, so let's start with triangle MRN congruent to QRP. So that's given to us. We don't have to say that those are congruent. We don't have to prove that those are congruent. It's given. Okay, one thing I want to be kind of clear on too is the triangles that we are trying to prove are congruent, and that is M and P, kind of this long guy, and QPN. QPN is this, so another kind of two long triangles that kind of overlap there. Okay, so the angle that they're giving us, sorry I didn't draw these very well, but the angle that they're giving us that are marked congruent, that's MNP, that's this guy, and then QPN, which is this guy. So notice that it's not this angle, it's this angle, okay, and this angle. All right, so what we're going to start with is the first given, okay? So we know that this blue triangle is congruent to this blue triangle, okay? That's just given, okay? We don't have to worry about that. When we have two triangles congruent, we get 6 pieces of information, okay? CPCTC stands for corresponding parts of congruent triangles are congruent. But how many corresponding parts are there for these two triangles? There's 6 pairs of corresponding parts. We got MR congruent to QR, we got MN congruent to QP, we got NR congruent to PR, we got this angle congruent to this angle, we got this angle congruent to this angle, and so on. There's 6 different pieces there. Now really the pieces that we need are this guy and this guy. Okay? So we're talking about, we start with these little triangles, we're trying to prove something about the big larger triangles. So we got those two congruent. Also, I want you to notice that the bottom of these are the same. Like I pulled them apart, but they both share this bottom NP segment, right? And NP is congruent to itself, so those guys are going to be congruent. And you got it. That's SAS right there. So how do we get this side and congruent to this side? That was from CPCTC. These two triangles are congruent to each other. Therefore, this side is congruent to this side. But remember that those sides are part of the small blue triangles and part of the larger triangles that I drew over here. So CPCTC, when you know these two blue triangles are congruent, you know all their parts, their corresponding parts are congruent, which means that these are congruent. Okay, so CPCTC there. Okay, how do you get these guys? Reflexive property of segment congruence, right? Or congruent segments. They share that bottom. Okay, how do you get this angle congruent to this angle? It was given. It's right there. It's the second line. Okay, so side, angle, side. Angles given. This comes from CPCTC. This comes from reflexive property. Boom, SAS. You're going to prove this one by SAS, and I've just shown you how to get the two sides and their included angle. All right, last one. Here we go. Okay, now this is really similar to number 2, almost identical to number 2. So if you got number 2, then this one should be pretty easy. Couple things to note. First of all, we got AB congruent to CD. They are marked that way, but they are also, that's stated in the given. Okay, we also got AB parallel to CD. That's this symbol right here. Okay, so they're parallel. And remember, whenever you see parallel, you should start thinking alternate interior angles. So there are your alternate interior angles. Okay, so just to kind of clarify, if we did this off to the side, right, these are alternate interior angles right here. Now, sometimes people are like, well, what about the other ones? You also got these alternate interior angles. That's true, you would, but think about it this way. If I extend this out, my alternate interior angle isn't this little tiny angle right here. It's this full angle out here. So you got to be careful with that. When you're looking at, like, this is the acute alternate interior, you have this obtuse alternate interior angle, but this angle of the triangle is not the same as the full angle that you get with by the transversal. So these are the two that you want marked parallel here, or excuse me, marked congruent. Okay, so we got side, we got angle. The last side comes from the reflexive property. CB is congruent to BC by reflexive property. So you're going to prove this one by side angle side. Okay, the first side is given to you, no problem. The other side comes from reflexive property, and the angle comes from alternate interior angles theorem. Okay, again, very, very much like problem number 2. So if you need help with that, go back and watch kind of the proof of problem number 2, and that should help you out a lot. Okay, so we went through all of them. You just got to write the proofs here, but the reasoning I gave you. Okay, hope that helps, and I'll see you guys back in class soon.